Howdy, class. So I realize that some of you might be a little rusty on what a logarithm is or how to work with it. So we're just going to do a really quick review before getting into the actual handout for today. So the first off, many of y'all know what an exponential is, but let's go ahead and take a look at it. An exponential is y equals, some base. We'll say b. Raised to the x, where b's got to be some positive number. It can't be 0, but just a positive number. Now, this graph, when you graph this, it's going to look like this. That's the line y equals b to the x. Assuming that b is more than 1 in this case. If b is less than 1, it looks a little different, but in general, that's what it's going to be. And so if you compare this to the graph y equals x, what you notice right away is that y equals b to the x is shooting up much faster. It's approaching infinity much, much faster than if it were approaching linearly, like this guy is. The human brain has a very hard time comprehending exponential because it increases so much. We're not going to get into this, but this is why we have what are called log graphs. It's because it turns an exponential into a straight line so the human mind can actually see what's going on. And these are used quite often in production decline curves for oil and gas, or anything else that is exponential in nature. All right, so you may be thinking, what are some other applications? You guys are all business majors, since this is a business cal class. So let's take a look at the compound interest equation, right? You've got y equals, or I'm sorry, A equals, which is the amount due, equals the principal, the original amount borrowed. That you guys should have a good handle on this. 1 plus r divided by n, where n is the number of compounds, raised to the nt. Whereas a reminder, and as business students, you guys should be very familiar with this equation. This equation should be second nature to you as you go through your business classes, even those that are not specifically math. So what is n? N is the number of compounds. What is t? T is the number of years. But let's break this down just a little bit. So the amount that's owed as time progresses, it's changing, right? It's increasing. And if we just say, well, what if we group this all together, right? Because the number of compounds per year is constant. The rate is constant, right? The interest rate per year, of course, 1 is constant. And so we can kind of just lump all this together into one term, and we'll call it b, right? And then that'll be raised to the t. Well, what does this look like? It looks like an exponential equation, doesn't it? If we take the a and make that a y, and just kind of redefine that variable as to be a y, well, all of a sudden, this looks very similar to what we have over here. So this exponential equation is very important. You should become very familiar with it if you are doing any kind of financing at all. And this kind of, when you get into how quickly exponential rate grows, you begin to understand the influence, the power of compound interest, because things just tend to grow exponentially at this rate. All right, so that's why this is important. Let's go ahead and talk a little bit about the properties of this. The inverse of the exponential. If you're working with it and you're trying to figure out, okay, well, what I need to know what that term is. Well, you could take the logarithm of both sides. So why don't we go into what a logarithm is first before getting into that. Log b of x. Well, what we're saying is, all right, what's and say y. Let's keep it in terms of. Let's get rid of the variables actually. So let's say this is c and I can't. Let's call this d. Why not? So what we're really saying here, is what exponent do I have to put on b? Maybe keep this as a variable. I kind of like that there. What exponent do I have to put on b, because x is the unknown, to get d, right? What do I have to put here in order to turn this into d? That's what it's asking. So a quick example. If I said log base 2 of, say, 8. What we're saying is, what exponent do I have to put on the 2 to get to 8? And we can kind of right, 2 cubed is 8. So the answer to this question is, what exponent do I have to put on this 2 to get this number here? Well, clearly, it's got to be 3. And that's how it works. And so let's do one more example. Let's say I got log base 3 of 27. So we're saying here, what exponent do I have to put on 3 to get to 27? That's what's being asked. And so log base 3 is going to be, well, 3 to what power is 27? Well, we know that 3 squared is 9, and then 9 times 3 is 27. Let's go ahead and put a big parentheses there, right? This is, 9 times 3. 9 times 3 is 27. And so we've got this extra 3 right here, so we're going to go ahead and combine these guys so that we've got log base 3 of 3 to the 3rd power. So we see that we need an exponent of 3 to get 3 to 27. So the answer is 3. Now let's look at another one, because you might be telling me when you look on your calculator, you don't see the base number, you see a regular log, and you might see something like this, log 100. Well, what this means, this is called a common log. This just means that it's a log base 10. And 10 squared is 100, so the answer is 2. And the other one you're going to see a lot, we're going to talk about this one a lot, is the natural log of some number. We'll say of 5. Well, this would be log base e of 5. Now this one you'd have to plug into your calculator to actually figure out. This is not one you can just do easily in your head. But we're just trying to figure out, okay, e, which is a irrational number, what exponent do I have to put on e in order to get to 5? And you can kind of, in your head, you kind of go, okay, so e is, let me see, put it over here. E is 2.718, it goes on and on. That's got to be, if you just put to the first power, it'll be this. And if you put it to the second power, it's going to be more than 4. So, it'll be around 2-ish when you plug it in. Without actually throwing it in the calculator, I'm not exactly sure what it would be, but you get the idea. We're just trying to figure out what exponent you have to put on here to get this number here. All right, so for instance, if I said, what is the natural log of e to the 5th power? Let's use a different number, 6th power. Well, the answer would be 6. And just so you know, that's log base e of e to the 6th. Answer is 6. That's how that works. All right, so let's do a quick algebraic example here. If I have, say, 100 equals 10 raised to the x. And I want to know, what does x equal? What do? Well, I got to take the log, the common log of both sides. So we're going to go ahead and take the log of this side, that's base 10, log right here, base 10. All right, so when we break this down, this becomes, log of 10 squared and log of 10 raised to the x. So clearly on the left-hand side, there's a, don't forget, that's what that means, right? That's the base 10. So what exponent do I have to put on 10 to get 10 squared? Well, that's 2. What exponent do I have to put on 10 to get 10 raised to the x? Well, it's just x. And so in order for this to work, x equals 2. And when you kind of throw that in there, it makes sense if you plug it back in. All right, so that's just a very quick and dirty review of logarithms and exponentials. It's very important that you realize what these are moving into the next lesson, and it's also incredibly important in your coursework, particularly since you guys are business students and you really need to understand how compound interest works. And if you don't understand these two functions, you will not understand how the interest works. All right, so make sure you watch the next video today that I'm going to be posting.